Dear friends, welcome to the video content on gravitation. In this tutorial, we will learn what is gravitation, universal law of gravitation, free fall, value of g, motion of objects under gravity, mass, weight, weight of an object on moon, thrust and pressure, pressure in fluids, buoyancy, why objects float or sink, Archimedes Principle and relative density. So let's begin. What is a gravitation? Gravitation or gravity is a natural phenomenon by which all physical bodies attract each other. It is most commonly recognized and experienced as the agent that gives weight to physical objects and causes physical objects to fall towards the ground when dropped from a particular height. Sir Isaac Newton was an English physicist who gave the universal law of gravitation. So let's see what is a universal law of gravitation. The universal law of gravitation states that any two bodies in the universe attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. It is given by the following mathematical equation: F equal to G multiplied by m1 into m2 by r square, where G is the constant of proportionality and is called the universal gravitation constant. Here m1 and m2 are the masses of object 1 and object 2, and r is the distance between both the objects. The accepted value of G is 6.673 multiplied by 10 raised to the power minus 11 Newton meter square kg minus 2 square. The law is universal in the sense that it is applicable to all bodies, whether the bodies are big or small, whether they are celestial or terrestrial. Now let's understand what is a free fall. Let's know it by doing the following activity. Take a ball, throw it upwards. Notice that when it reaches a certain height, then it starts falling down. This is because Earth attracts objects towards it due to the gravitational force. During free fall, there is no change in the direction of motion of the objects, but there will be a change in the magnitude of the velocity and therefore acceleration of the objects. Let us know what is acceleration due to gravity. Whenever an object falls towards the earth, an acceleration is involved due to the earth's gravitational force. This acceleration is called the acceleration due to the gravitational force of the earth, or acceleration due to gravity. It is denoted by g and its unit is ms minus 2 square. The earth is not a perfect sphere. As the radius of the earth increases from the poles to the equator, the value of g becomes greater at the poles than at the equator. Value of g can be calculated by the following equation. G equals capital G multiplied by m divided by r square, where universal gravitational constant g equals 6.7 multiplied by 10 raised to the power minus 11 Newton m square kg minus 2 square. Mass of the earth m equals 6 multiplied by 10 raised to the power 24 kg, and radius of the earth r equals 6.4 multiplied by 10 raised to the power 6 m. Thus, the value of acceleration due to gravity of the earth g equals 9.8 m s raised to the power minus 2. Now let's understand how the motion of objects is influenced under gravitational forces. For this, we'll perform the following activity. Take a sheet of paper and a stone and drop them simultaneously from the first floor of a building. Observe whether both of them reach the ground simultaneously. You will observe that the paper reaches the ground little later than the stone, which happens due to air resistance. The air offers resistance due to friction to the motion of the falling objects, and the resistance offered by air to the paper is more than the resistance offered to the stone. Let's understand this in mathematical form. As g is constant near the earth, all the equations for the uniformly accelerated motion of objects become valid with acceleration a replaced by g. Thus, the equations are v equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as, where u and v are the initial and final velocities and s is the distance covered in time t. On applying these equations, we will take acceleration a to be positive when it is in the direction of the velocity, that is in the direction of motion. The acceleration a will be taken as negative when it opposes the motion. We will study next a very often heard term, mass. What is mass? The mass of an object is the measure of its inertia, and it is denoted by m, small m. Mass and inertia are directly proportional to each other, and therefore greater the mass, the greater is the inertia. Also, the mass of an object is constant and does not change from place to place. Now let's see what is weight. The weight of an object is the force with which it is attracted towards the earth, and it is denoted by W. Weight has the same SI unit as that of the force, that is Newton. The mass of an object remains the same everywhere, that is on Earth and on any planet, whereas its weight depends on its location. So friends, what will be an object's weight on Moon? Can you think of it? Will it be higher or lesser? Let's see. Weight of an object on the Moon is the force with which the Moon attracts that object, and it is denoted by Wm. The mass of the Moon is less than that of the Earth, hence it exerts lesser force of attraction on objects. Weight of the object on Moon is given by Wm equals g multiplied by capital M into m divided by r square, where Wm is weight on the Moon, mm is mass of the Moon, and rr is the radius of the Moon. The weight of an object on the Moon is 1/6 of its weight on the Earth. Let's take an example for better clarity. If an object weighs 10 n when measured on the surface of the Earth, what would be its weight when measured on the surface of the Moon? Let's see its solution. We know that weight of the object on the Moon equals 1/6 of its weight on the Earth, that is Wm equals We divided by 6. Therefore, when we put the value given in the question, that is 10 Newton, in the equation here, we get 10 divided by 6n, that results to 1.67 Newton. Thus, the weight of object on the surface of the moon would be 1.67 newtons. Now let's understand the terms thrust and pressure. The force acting on an object perpendicular to the surface is called thrust, and the thrust on unit area is called the pressure. Therefore, pressure is thrust divided by area. The SI unit of pressure is called Pascal. Pressure in fluids. All liquids and gases are fluids. As solid exerts pressure on a surface due to its weight, similarly fluids have weight and they also exert pressure on the base and walls of the container in which they are enclosed. Pressure exerted in any confined mass of fluid is transmitted undiminished in all directions. Now let's understand what is buoyancy. The upward force exerted by the water on an object is known as upthrust or buoyant force. All objects experience a force of buoyancy when they are immersed in a fluid. Let's understand buoyancy with an example. Take an empty plastic bottle, close the mouth of the bottle with an airtight stopper, put it in a bucket filled with water. You see that the bottle floats. When you push the bottle into the water, you feel an upward push. Try to push it further down. You will find it difficult to push deeper and deeper. This indicates that water exerts a force on the bottle in the upward direction. The upward force exerted by the water goes on increasing as the bottle is pushed deeper till it is completely immersed. The magnitude of this buoyant force depends on the density of the fluid. Now, you may be curious to know that why do the objects float or sink? The force due to the gravitational attraction of the earth on an object pulls it downwards, while there is an upthrust of water on the object which pushes it upwards. When the downward force acting on the object is greater than the upthrust of water on the object, then the object sinks. And note, when the upthrust of water on the object is greater than the downward force acting on the object, then the object floats. Now let's study what is Archimedes Principle. It states that when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. It's generally applied in designing ships and submarines, and also lactometers and hydrometers are based on this principle. Lastly, let's see what is relative density. The density of a substance is defined as mass of a unit volume. The unit of density is kilogram per meter cube, and it is different for different substances. For example, the density of gold is 19300 kg meter cube, while that of water is 1000 kilogram meter cube. The relative density of a substance is the ratio of its density to that of water, and it is given by relative density equals density of a substance divided by the density of water. Thank you. Hope you enjoyed learning with me. See you in next tutorial.